Operation Q was the name given the Nevada test in 1955, designed to explore the effects of small nuclear weapons upon buildings, towers, and equipment of many kinds. The nuclear device used was comparatively small. It had an explosive force of 30 kilotons, equivalent to 30,000 tons of TNT, whereas some modern thermonuclear weapons are in the 20 megaton range, 20 million tons, more than 600 times as powerful as the bomb shown here, and with a much wider radius of destruction. In this test, many of the structures damaged by the 30 kiloton bomb were approximately 1 mile from ground zero. With a 20 megaton blast, they probably would be obliterated, and comparable damage would occur out to a distance of at least 8.5 or 9 miles. Therefore, while Operation Q was valuable for research and test purposes, it does not reflect the full severity of today's larger thermonuclear weapons with their associated fallout hazard.
The Atomic Energy Commission's Nevada test site, I covered the story of Operation Q, a program to test the effects of an atomic blast upon the things we use in our everyday lives. As a reporter, I wanted to see Operation Q through my own eyes and through the eyes of the average citizen. I arrived at Civil Defense Headquarters the day before the explosion was scheduled to take place and checked in at once with an official for a briefing on the test. To give me a perspective of the entire test layout, a member of the Civil Defense staff showed me a carefully prepared model of the site. He explained the scope of the test and the detailed care with which it had been planned.
We begin with the question of shelter, for shelter might save the lives of those far enough from ground zero. But what kinds of shelter are effective? Several types are to be tested, from elaborate industrial shelters to a box-like family shelter in the corner room of a basement. In this frame house without a basement, at the 4,700-foot line, we will test a bathroom shelter built of reinforced concrete. The entrance door and outside window covering are designed to resist blast. Loss of power may be one of the biggest problems after an attack. Power poles, power lines, pole transformers, and complete substations are to be tested by the Edison Institute. We hope to learn the answers to these questions. How will they withstand this blast? How long will it take to make repairs? How soon can service be reestablished? One complete transformer substation has been erected relatively close to the shot tower. A second substation and power lines have been placed at a much greater distance from the tower. Two kinds of radio towers are to be tested. One tower is self-supporting without guy wires, and the other has supporting cables. Both types are very common. Nearby, a complete radio transmitter will actually broadcast from tape before the shot to be picked up by radios in the test houses. Both liquefied petroleum and natural gas facilities will be tested. Our questions: will the fittings and connections stand the test? Will there be fires? All equipment is installed and checked by experts from the LP Gas Association and the American Gas Association. This is an 18,000-gallon supply tank, partially filled with propane and complete with feed pipes. Here, a weighing and storage house and delivery platform have been erected on the test site.
I was eager to learn all I could about the various types of houses to be tested.
5 types are to be exposed to the blast and heat of this atomic explosion. First, a single-story frame rambler without basement, built on a concrete slab. Second, a 2-story masonry home with basement, constructed of brick, backed with 4-inch cinder block. Third, a house of 8-inch concrete blocks reinforced with steel. A fourth is a single-story rambler made of precast lightweight concrete. Walls and roof panels are joined by steel lugs. The fifth, at a 5,500-foot line, is a house similar to one previously tested in 1950, but a new design provides additional strength at a cost increase of approximately 10%. That's the real purpose of testing these houses, to find their weak points.
Through the cooperation of the furniture and appliance industries, household furnishings were installed in the houses. Mannequin families were supplied by private industry. Interior home furnishings, also donated by industry, were complete in every detail. Textiles and synthetic fabrics were also to be tested.
Rows of mannequins are set up in the open facing the blast. Each item of clothing and each color has been carefully selected.
As a mother and housewife, I was particularly interested in the food test program, a test that included canned and packaged foods.
Some foods are to be tested in the house, stored in the usual way. Other foods, including fresh meats, butter, and similar perishables, are to be tested just below the level of the ground at 3 positions along the main test line. This will expose the food to high-intensity radiation without risking destruction of the containers. Test items include sterilized foods packaged in cartons, metal, and glass. All will be exposed according to plan to give us the most information.
The night of the actual explosion, or rather early in the morning, finally came. On Media Hill, television equipment was positioned. Reporters, commentators, military and civil defense observers all had one purpose: to study the results of this explosion. At a position a mile forward from Media Hill, the Civil Defense Field Exercise Group had assembled with their equipment. A small group of civil defense volunteers were to occupy a trench relatively close to ground zero. On Media Hill, where I remained, there was hot coffee, last-minute briefings, and more waiting.
Minus 1 minute. Put on your goggles. Observers without goggles must face away from the blast.
On the silent desert, the test objects waited.
H minus 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
24 hours elapsed before we were permitted to view at first hand the results of the explosion.
This is what remained of the masonry house that was not reinforced. This is the house constructed of reinforced concrete blocks after the explosion. Although the redesigned two-story frame house was severely damaged, the structural improvements had strengthened its resistance considerably. The basement shelter had offered some degree of protection. The reinforced bathroom shelter was standing intact beneath the ruins of the house, so this type also offered some degree of protection. The upper section of one unguided radio tower collapsed from the tremendous force of the blast. The guide tower was slightly twisted by a power pole which fell across one of the guy wires. Within the concrete radio house, equipment had been shaken up, but as soon as power was restored, the transmitter resumed broadcasting. The 18,000-gallon tank of liquefied petroleum gas was undamaged. The connections were intact. The weighing and storage house was scattered across the desert, but the consumer-sized tanks were unharmed. Power lines and transformers suffered some damage, but most of the power poles were still standing or could be repaired. The power substation was not seriously harmed. Edison Institute experts tested all lines and found the station to be operative. The food and cases of canned goods were taken away for laboratory tests.
A tattoo mark was left beneath the dark pattern of this dress. The blast charred and faded the outer layer of this dark suit. During all this activity, the mass feeding group had been improvising to feed the test observers. These cans could have been salvaged from demolished buildings and used for preparing meat. As I watched the people eating, I realized that mass feeding would be an important job for civil defense. I took a last look at the debris and devastation. This time, it was only a test, a well-planned test, not a real attack. It was a test of the things we use in everyday life.
Multi-megaton weapons would result in much greater damage over a larger area. But many lessons were learned from this test that have affected civil defense planning. All these factors must be considered as we plan for the survival of our homes, our families, and our nation in the nuclear age.